In today's video, I'm going to give an overview on how to tune a car audio system using a Audison Forza DSP amplifier. The vehicle I'll be using for this demonstration is a 2022 Hyundai Elantra N. Even though this is an overview that pertains to all vehicles, I'll be going over tuning parameters that are specific to the Hyundai Elantra that's equipped with the Bose premium audio system. These specifics will help tuning the Elantra whether you're using the Forza DSP or any other brand's DSP. Before we're able to begin tuning, there's a few things we need to do to get the car ready. First, I would recommend hooking up a battery maintainer. This is an inexpensive item that will help to ensure that you don't drain your car's battery while tuning, since the tuning process should be performed while the car is not running. Before I had one, I found that I would drain my battery pretty quickly without realizing it. Draining your car's battery is not good for it and will shorten its lifespan. This is why a battery maintainer is a good tool to have in your garage. I will have a link to the one that I use along with the other items used in this video down in the video description. The second tool that you'll need is Audison's test tracks. These test tracks can be downloaded from Audison's website for free. There are specific tracks for the Forza line of DSPs. You will go to audison.com support test tracks. There are 6 tracks in the downloadable file. You may save the files to a USB drive or to your cell phone. I will have a link to the tracks in the video description. A third tool that you'll need is a multimeter with a voltmeter and an oscilloscope. You can purchase these as separate tools. I prefer having fewer tools if possible. That's why I purchased a multimeter that has both built in. Both of these types of tools will be used to perform 2 tests on the signal outputs of the factory audio system. First, we need to find out what is the maximum volume the system can be turned up to and still maintain a clean signal. Second, we need to find what is the voltage of the signal being sent out at the volume determined by the first test. To perform both tests, we need to tap into the signal wires we plan to connect the DSP amplifier for input signal. In my case, I chose to use the front left and right channels for signal as these have a full range signal. To connect the voltmeter and oscilloscope, I needed to tap into the factory signal wires coming off the Bose amplifier. I already had them hooked up to my DSP, but because I cut the wires and attached insulated spade connectors, it was easy to unhook the wires at the Bose amplifier and connect a positive and negative test wire to one of the 2 front channels. With the test wires connected, I attached the voltmeter's positive and negative leads to the corresponding wires. I turned the multimeter to oscilloscope mode. I then played a 40 Hz test tone using a test tone generator app. I turned the volume to 34, which is 75% of the total max volume of 45. I watched the oscilloscope as I turned up the volume in 1-notch increments to see when the sine wave flattened at its peak. A clean signal should have a round peak, whereas a distorted or clipped signal will be flat. For the Elantra, 38 is the max volume with a clean, undistorted signal when using the front inputs. With this knowledge, I knew what my max volume could be turned to and still have a clean signal. After I found what my max volume could be, I switched the multimeter to AC volts and checked what the voltage was at volume 38 while still running the test tone. I showed that the volume to be 6.39 volts. This will be helpful when setting the input sensitivity in the DSP. Finally, you'll need a microphone. I chose to use a UMIC 1 microphone by Mini DSP. This is an easy-to-use plug-and-play USB microphone. The microphone comes with a small tripod. I found I was able to use the tripod to position the microphone to my car's seat headrest and then use tape to hold the microphone in place. Most microphones will come with a calibration file or files. These are required to ensure the microphone is set up properly for testing. You will download the file or files from the manufacturer's website and then load the correct file in the DSP software. The UMIC 1 has 2 files. The first is the default file, which is used when facing the microphone forward. The second file is a 90-degree file, which is used when facing the microphone up. We can now connect our Forza DSP and microphone to a Windows laptop. Audison provides you with a USB cable to connect your DSP to a laptop, but it's not very long, so I would suggest getting a USB extension cable. I have one permanently installed in my car. When it's not in use, I hide it between the rear seat cushions. I use a small Velcro strap to help keep the wire wound up. The DSP connected to the computer, we're ready to begin the tuning process. We begin by opening the Bit Drive software and clicking on the model number of the DSP you have installed. Locate the music note at the top of the screen and click on it. A box will pop up. In the first drop-down box, find and select your microphone and click on it. You can leave the next two boxes in their default settings. The last box has a folder next to it. Click on the folder. A file folder selection window will open. Locate the microphone calibration file that you want to use. Click on the file so it populates the last box, then click OK. For my setup, I used the 90-degree file and placed the end of the microphone facing the car's roof. At the top of the software, there is a magic wand. When you click on the wand, two options are available: the Configuration Wizard and Accordo Wizard. You'll want to select the Configuration Wizard first. This helps to make setting up the amplifier's inputs and outputs easier. The wizard is designed to walk you through the setup process step by step by asking you questions or by having you play certain test tracks. You can skip some of the steps if you would like to perform them manually. The first question is, will you be using an optical input? If you're not using a source with an optical output, uncheck this box. If you add an optical source later, you can always change this setting. Click Next. Next is the Input Configuration section. In my case, I was using high-level signal from the factory audio system, so I left the high-level, low-level slider at the default high-level setting. The high-level signal is only coming from the front two channels, so I clicked on the first box that says Front. By selecting this box, input 1 and 2 will automatically set to left full and right full. Now click Next. On the next screen, you can set the input sensitivity manually or allow the system to set it automatically. We already measured the signal voltage being sent out of the factory system, which was a maximum of 6.39 volts. This means we can use the drop-down box and select the closest value, which is 6.6 volts, and then click Next. If you want to use the automatic function, play the Audison Test Track 1 sine sweep. Make sure your head unit's volume is at 38 or at its highest unclipped volume. Also, make sure your fader, bass, and treble are all set to 0. Click on Start. It takes less than 2 minutes per channel for this process to finish. Let's test the automatic feature and see what it sets the input sensitivity to. I've sped up the process and it looks like the system set the sensitivity to 8.8 volts for both channels. This is higher than what I'm showing with the O-scope, so I changed this manually. Click Next. On the next screen, you will be asked to play track 3, Pulses, and hit Start. This test is to find out if your input wires are correct and if each channel is in phase. If the channel is out of phase, as you see in my test, you can switch the wires manually or allow the system to change the phase 180 degrees. For some reason, this was inaccurate, as I checked my wires after the test. I also checked this during the DEQ phase, and my channels were in fact in phase. Speaking of DEQ, that is the next screen. You will use this feature to remove the factory EQ. To do this, you will play the track 1 sine sweep again and hit Start. Typically, this is good to use for simple full-range left and right signals like I'm using. Unfortunately, like I'll show later, it had trouble compensating for an all-pass filter that I have on my right channel, so I had to DEQ the system manually. That is why I would suggest skipping this step if you are an Elantra N owner. Next, we need to set the output channels. You can choose from one of the preset configurations that's the closest match to your system, or you can select each channel manually. I chose to set my outputs manually. Output 1 was for my front left tweeter. After selecting the speaker type, if you're using an Audison or Hertz brand of speaker, you can tell the DSP which speaker you're using and it will automatically set the recommended crossover for that speaker. When I selected my channel 3 speaker, I chose front left woofer Milli Pro, then I clicked on the bridge toggle switch. when I wired up my mid-woofer to be bridged between channel 3 and 4 and 5 and 6. If you bridge any of the channels, you must tell the software that this is how the amplifier has been wired so it will work properly. Once you've selected all your outputs, you can click on Next. The final step is volatile data. I left all these settings in their default configuration. Click Next, then click Done. This completes the configuration wizard. Next, we'll move on to manually de-EQing the system. We have to perform this step before we can move on to the Accordo wizard, since you need a flat input signal for best results while tuning. Previously, I purchased a DSP from Mini DSP. It was a very nice DSP, but I didn't purchase the Direct Live automatic tuning software license. The DSP allows you to easily import files from REW tuning software, so I figured I would use REW's automatic tuning function to help tune my system. The issue I found was that REW didn't allow me to tune the input signal coming from the factory source. REW works great if you already have a flat signal, such as one from an aftermarket head unit. Upon further investigation, whether or not I should upgrade my Mini DSP by purchasing the Direct Live license, I found Direct Live also didn't correct input signal issues. So I began looking for a DSP that would allow me to make the corrections to the input signal since I wanted to use my factory head unit as my source. I found two really good DSPs as options, Helix and Audison Forza. I ended up choosing the Audison Forza DSP amp based on two factors. One, I liked that the DSP and amplifier were built into one unit. This cut down on my stereo components. And yes, I know you can purchase a DSP amp combo from Helix as well, but that brings me to my second deciding factor, and that was I tested both companies' software and I preferred the experience I had while using Audison software. Either of these choices would have been good. I couldn't have made a bad choice here. Now on to how to de-EQ or flatten input signal with the input EQ. First, begin playing track 4, Pink Noise, and turn the volume to the maximum unclipped volume, or in my case, 38. Next, in the DSP's software, click on Inputs, and then click on the icon with the arrow pointing up and an arrow pointing down at the end of the Inputs section. This will open the Input RTA. You'll need to click on the eyeball icons in the upper right of the screen. They will have a 1 and 2 next to them. By clicking on the eyeball, you can toggle the left and right input signal on and off. If you run the automatic DEQ in the Setup Wizard, those corrections will be displayed. To make corrections, you need to click on the channel on the bottom left of the screen that you want to work on. Make sure the input you're viewing is the same channel that you've selected to work on. For example, click on the eyeball labeled 1 and then click on the input at the bottom labeled 1. Before making changes to the peaks and valleys, you'll want to determine if there are any all-pass filters or comb filters in the input signal. An all-pass filter will be a large dip in the signal. A comb filter will be a series of dips in the signal. To counter an all-pass filter, you need to place another all-pass filter on one of the channels where the large dip is. To counter comb filtering, you need to add delay to the signal. If the Setup Wizard added delay to one or both of your channels and you notice you have comb filtering, you may need to reduce or remove the delay added by the Setup Wizard. For the Elantra's Bose system, an all-pass filter was used. To counter this, I added an all-pass filter to the right channel at around 250 Hz. For the rest of the signal, I looked at each peak and valley, chose the center frequency of the peak or valley, then selected an EQ channel, and began correcting the curve. Since we were using a parametric EQ, you can adjust the boost or cut along with the Q or width of correction the boost or cut will affect. Make the adjustments slowly as there is a slight delay in the RTA. For the Elantra, I found two large peaks on the front channels at around 500 and 1700 Hz that needed to be brought down. And then the lowest frequency, around 25 to 30 Hz, needed to be boosted. Don't worry about how much boost that you add to the input. This is not the same as tuning the output signal. Goal is to get as flat of a signal as possible from 20 Hz to 20,000 kHz. The software allows you to overlay a target curve for a visual aid. To overlay a flat target curve, Click on the small arrow on the right of the screen. Click on the target curve icon. The flat curve is the default curve, so just click OK at the bottom of the screen. This will place a flat curve on the input RTA. After making changes to each channel signal and getting it as close to flat as possible, you'll want to test the channels together. You should see the signal go up when they are combined. If they go down, one channel is out of phase. Now that we have a flat input signal to work with, we can proceed with the Accordo automatic tuning feature. You can also tune the system manually if you wish. The Audison Forza DSP software makes this easy to do. I will touch on manual tuning after we go through the automatic process. For my vehicle's tuning, I chose to manually set the system's time delay and make adjustments to the Audison pre-selected crossovers. To set the delay, I measured the distance from the middle of each speaker to the tip of the microphone and entered those values in the DSP software in inches. I changed the crossovers because I felt the ones set by the system were a little too high when switching from the tweeter to the woofer. To change the crossovers, click on the channel you want to change. Under the delay box will be a crossover box where you can enter the crossover value you want to use. Go back to the top of the main screen and locate the magic wand again, then click on it. Under the drop-down box, click on Accordo Wizard. Accordo's main screen will provide a checklist of items you need to make sure have been checked before proceeding with the automatic tuning process. Once you've verified all items have been completed, click Start. Accordo can perform 3 separate functions: level alignment, time alignment, and EQ. You may deselect any of these functions if you wish to perform the function manually. Click Next after you've decided on which functions you'd like the software to perform. I chose to allow the software to perform all these functions. Before Accordo runs, it will test the outputs to make sure that they are all working properly. If there's anything wrong with a channel, it will show in the channel info column. If everything shows OK, click Next. The target curve section allows you to choose a target curve the software will use as a reference to set the speaker's EQ curve to. You can choose one of 5 preloaded curves, upload a curve that you have saved on your computer, or create your own curve. I chose to use one of the preloaded curves, which was the HAC-E curve. This curve tapers off the high-end frequencies and provides a nice boost in the lower frequencies. The next screen is the automatic calibration section. This screen allows you to set a timer for when the automatic process will begin. This is useful if you're setting everything up while sitting in the car and need time to exit the vehicle before the process begins. I was sitting outside the car, so I just left it at its default 5 seconds. The other option is setting the subwoofer level. This is done based on what type of controller you're using for the subwoofer volume control. You can select an Audison controller, the subwoofer's amplifier bass knob, or no controller. I chose no controller since I decided not to use any type of volume knob for the subwoofer. I find once I set my subwoofer's level, I don't really change it. After you've made your selection, click Start. The system will count down based on the previous timer selection, and then the automatic tuning process will begin. As part of most recent updates to the software, the system will perform a microphone calibration test for each speaker. Before the update, it performed a more basic test, which I ran into issues with the software detecting my microphone. To solve this issue, you had to remove the bottom of the microphone to gain access to the board inside the mic, and then switch a jumper to change the microphone's sensitivity. Audison's latest update has solved this issue, so you no longer need to open up the microphone. After the test has finished, click Next. Here you get a second chance to change the time of when you need to exit the vehicle. Again, I was outside the car, so I left the default setting to 5 seconds. Click Start. This process will take less than a minute to complete. Once done, click Next. The software will remind you to finalize and save the tune to your PC. Click Done. You will see the screen go gray for a few seconds while the tune is written to the DSP's memory. After the gray screen turns back to full color, go to the top left of the screen. Click on the up arrow icon. This will finalize the changes that you've made to the software. Then click on the disk icon to the left of the up arrow. This will let you save the tune to your computer. This completes the Accordo automatic tuning process. From here, you can listen to the sound system and make changes if needed. You can tweak each channel, or you can use the Final Tuning feature at the top right of the screen to make broad changes that will affect all speakers at the same time. I found this useful as I quickly and easily added a small dip to the upper mid-range frequencies. If you want to manually tune the system, you will go to the top of the screen and click on the microphone. Play the pink noise track. You should see bars moving in the section that displays the EQ changes. There is a box to the left of this section that will allow you to make the graph larger. Then, there are the graph scale limits that will let you size the graph so you can see the frequencies correctly. Under that is a target curve button. This will allow you to overlay the target curve you want to use for your system's tune. After you've selected the target curve, you can click on each channel and tune them individually. You have 2 ways to listen to the channel that you're working on. You can mute each channel individually by clicking on the speaker with the X beside it, or you can click on the ear on the channel that you're tuning to listen just to it. You will tune each channel similarly as the input channels. You want each speaker to follow the target curve that you've set. Audison does allow a third way to tune your system, and that is by using REW and then importing those tune files into the DSP. Helix and Mini DSP allow the same function. Please let me know who you like to use to tune your car and why. Your feedback could be very helpful for others to read. Also, if you have any questions regarding tuning, please feel free to ask it in the comments. I read all the comments and will do my best to answer your questions. Thank you for watching. Please like, share, and subscribe for more content.